In section 7.2, we're looking at linear functions and their graphs. All equations of the form ax plus by equals c are straight lines when graphed as long as a and b are not both 0. Such equations are called linear equations in two variables. We can quickly obtain the graph for equations in this form when none of a, b, or c is 0 by finding the points where the graph intersects the x-axis and the y-axis. The x-coordinate of the point where the graph intersects the x-axis is called the x-intercept, and the y-coordinate of the point where the graph intersects the y-axis is called the y-intercept. To locate the x-intercept, we're going to set y equal to 0 and solve the equation for x. And to locate the y-intercept, we set x equal to 0 and solve the equation for y. So you're letting the opposite variable be 0 and solving for the variable you're looking for. So for x, we let y be 0 and solve for x. And for the y-intercept, we set x to be 0 and solve for y. So using this method, we're going to graph 3x plus 2y equals 6. So let's go ahead and do the x-intercept first. And that's when we let y be equal to 0. So we have 3x plus 2 times 0 equals 6. Well, 2 times 0 is just 0. So 3x is equal to 6. And to undo our multiplication, we're going to divide both sides by 3. And so this ends up canceling on the left. And we get that x is equal to 2. We already know what the y-coordinate is because we let it be 0 to find the x-intercept. So we have the point 2, 0. We also want to find the y-intercept. And that's when we let x be 0. So we have 3 times 0 plus 2y equals 6. Well, 3 times 0 is just going to give me 0, and so I just have 2y equals 6 left over. To undo our multiplication, we're going to divide both sides by 2. And so it ends up canceling on the left, and we get that y is equal to 3. So again, we know the coordinate here because we let our x-coordinate be 0, and we figured out y was 3. So plotting our 2 points is all we need to make a line. So let's do 2, 0 first. We're going to go to the right 2 units, and then we're not moving up or down any. And then for 0, 3, we're not going to move to the left or right, but we're going to move up 3 units. And so now that I've plotted my 2 points, I can draw my line. And so that would be the line, or the graph of 3x plus 2y equals 6. Mathematicians have developed a useful measure of the steepness of a line called the slope of the line. Slopes compare the vertical change, or the rise, to the horizontal change, which is the run, when moving from one fixed point to another along the line. To calculate the slope of a line, we use a ratio that compares the change in y to the change in x. And so the definition of a slope says the slope of the line through the distinct points x1, y1, and x2, y2 is the change in y over the change in x, which is the rise over the run, or using our 2 points, we do y2 minus y1 over x2 minus x1. It is common notation to let the letter m represent the slope of a line. The letter m is used because it is the first letter of the French verb monter, which means to rise or to ascend. So let's go ahead and find the slope of the line passing through the pair of points. What's great about this is it doesn't matter which pair of points is x1, y1, and which one's x2, y2. As long as you keep the order the same on the top as you do on the bottom, you can put these in any order that you want to. I personally just label them as x1, y1 when it's the first set of points, but you can do it the other way. It does not matter. So for this first example, I'm going to label the coordinate -3, -1 as x1, y1, and -2, 4 as x2, y2. And so our slope formula, we have y2 minus y1 over x2 minus x1. And so y2 is 4 minus y1, which is -1. And then on the bottom, we have -2 as our x2 minus x1, which is -3. So in this case, we have double negatives both on the top and the bottom. And so we're going to end up with the 4 plus 1 and then a -2 plus 3. So 4 plus 1 on the top gives me 5. And then -2 plus 3 gives me 1. But 5 over 1 is just 5. Let's go ahead and try this with another pair of points. I'm going to label -3, 4 as x1, y1, and 2, -2 is x2, y2. So again, plugging into our formula, our y2 is -2 and y1 is 4. Our x2 is 2 and our x1 is -3. This time we have the double negative in the denominator. And in the top, we end up with a -6. And in the bottom, 2 plus 3 gives me 5. And so my answer, because this cannot be simplified any further, is just -6/5. This illustrates that a line with positive slope is rising from left to right, and a line with negative slope is falling from left to right. By contrast, a horizontal line neither rises nor falls and has a slope of 0, and a vertical line has no horizontal change. So x2 minus x1 does give me 0, but because we cannot divide by 0, the slope of a vertical line is undefined. So horizontal lines have a slope of 0, vertical lines have a slope that is undefined. We can use the definition of slope to write the equation of any non-vertical line with slope m and y-intercept b. And this is called the slope-intercept form of the equation. And that's y equals mx plus b. Here are two examples of slope-intercept form. We have y equals 2x minus 4, and so whatever number is attached to the x is going to be your slope, so in this case it's 2. And then the piece that's not attached to the x, or -4, is the y-intercept. And the other one, f of x equals 1/2 x plus 2. The 1/2 is going to be your slope, and your y-intercept would be 2. If a linear function's equation is in slope-intercept form, we can use the y-intercept and the slope to obtain its graph. In order to do this, we're going to plot the point containing the y-intercept on the y-axis first. This will be the point 0b. We obtain a second point using the slope. We'll write our slope as a fraction and then use rise over run starting at the point containing the y-intercept to plot the next point, and then use a straight edge to draw a line through the 2 points. We draw arrowheads at the end of the line to show that it continues indefinitely in both directions. So let's go ahead and look at example number 3. The first thing we need to know is what is the y-intercept, because that is the first thing that we're going to plot. So looking at y equals 2/3 x plus 2, remember it's the piece that is not attached to the x. And so my y-intercept is going to be the point 0, 2. And let's go ahead and plot that first. From this point, you're going to use the slope. So our slope in this case is the 2/3 that is attached to the x. And so with slope, we always have two options. Because I have a positive 2 on top, remember this is rise over run, that means we would be moving up 2 units and then to the right 3 units. But remember, we could write m as -2 divided by -3, and that would still give me a positive 2/3 because our negatives are going to cancel. But in this case, you would be going down 2 units and to the left 3 units. So we have two different options, and I'm going to show you how you move in both directions. Let's take the positive 2 over positive 3 first. You're going to go up 2 units from your y-intercept, and then you're going to go to the right 3 units. And then you're going to put your point here. Let's go in the other direction, just so you can see that it will fall on the same line. From our y-intercept, we would go down 2 units, and then to the left 3 units. And then plot our point. So ignoring the arrows, you can see that the blue, the black, and the pink point all fall in the same line. And so we're just going to connect our points and then put our arrows at the end. Let's go ahead and try another one. For example number 4, we want to graph using the slope-intercept and the slope and the y-intercept. And so we need to turn it into that form first. And remember that the form for slope-intercept is y equals mx plus b. So the goal is to get the y by itself. So we have 2x plus 5y equals 0. Well, let's go ahead and get y by itself. We're going to subtract 2x from both sides. And so it cancels on the left. We end up getting 5y equals -2x. And then we want to undo our multiplication, and we're going to divide by 5. And so we end up getting y equals -2/5 x. Now, what would be my y-intercept in this case? Well, there's nothing in that position, and so you can think of it as a 0. So your y-intercept is actually at the origin this time. It's at the point 0, 0. So let's go ahead and plot that. And my slope is -2/5. So with a -2, we're going to go down 2 units and a positive 5, we go to the right 5 units. Or, there's always going to be a second option. We can switch where the negative is at when we talk about fractions. So instead of it being attached to the 2, we can put the negative with the 5. And these are the same thing, they're equivalent. But in this case, the 2 is positive, so we go up 2 units. And the 5 is negative, so we would go to the left 5 units. And so let's go ahead and plot those points, and I will go both directions just so you can see. We're first going to go down 2 units, and then we're going to go to the right 5. Now let's go in the opposite direction. We're going to go up 2 units, and then we're going to go to the left 5 units. Now that we have all of our points, you can see that they fall in a line here. We can connect them. You only need to go in one direction to find the second point, but I'm just showing that you have options to go in either direction. And you're going to get the same line no matter what. Now let's talk about special types of lines, which are horizontal and vertical lines. If a line is horizontal, its slope is 0 or m is equal to 0. Thus, the equation y equals mx plus b just becomes y equals b, where b is the y-intercept. So all horizontal lines will have equations of the form y equals b. So there's no x present in the equation, it's only y and a number. The graph of x equals a is a vertical line where the x-intercept is a. So in this case, there's no y present in the equation and it's only x and a number. We want to graph y equals -4 and x equals 2 in the same rectangular coordinate system. Let's go ahead and look at y equals -4 first. Let's pretend that we didn't know that this was a horizontal line. What this is giving you a stipulation on is that y has to be -4. It doesn't say anything about what the x coordinate has to be. So I can pick whatever x values I want as long as y is equal to -4. So -1, -4 would satisfy that. 0, -4 would satisfy it. 1, -4. You could have 100, -4. As long as y is -4, then it follows the rule that was given. So let's go ahead and plot these 3 points, and then you'll see that you would get a horizontal line. We have -1, -4. We have 0, -4, and 1, -4. And so as you can see, when I connect these points, I get a horizontal line with a y-intercept at 0, -4. Let's go ahead and try the same concept with x equals 2. Now this time I'm giving you the requirement of x, but not telling you anything about y. So now we're just going to reverse it. As long as x is 2, I can pick whatever y value I want. So 2, -1 would be okay. 2, 0 would be okay. And 2, 1 would be okay. And these are just some examples. So you can, if you forget which form is a vertical and which one's a horizontal, you can always just apply this method and get the correct answer. So plotting these points, we have 2, -1. We have 2, 0, and 2, 1. And so you'll see that my line here is going to become a vertical line. And my x-intercept is at 2, 0. Slope is defined as a ratio of a change in y to a corresponding change in x. Slope can be interpreted as a rate of change in an implied situation. So let's take a look at the last example. The line graphs in the figures show the percentage of American men and women ages 20 to 24 who were married from 1970 through 2010. Find the slope of the line segment representing women and describe what the slope represents. So we're looking at the women line, which is just the blue line, and we're given two coordinates here. We have the point 1970, 65, and we were also given another point, which was 2010, 21. And so we can figure out the slope with these 2 points. We have x1, y1, and we have x2, y2. So let's go ahead and plug this into our formula for slope. So we have 21 minus 65 all over 2010 minus 1970. And so on top we end up with a negative 44. And on the bottom I have a 40. Now we can divide both the top and bottom by 4 to simplify, which will give me negative 11 over 10. And let's go ahead and just write the decimal. If we were to type this into our calculator, we would get negative 1.1. So our slope here in both forms is negative 11 over 10 or negative 1.1. So what does the slope represent here? Well, the title of the graph is the percentage of Americans ages 20 to 24 who are married. The X is the year, and the Y is the percentage of, in this case, women who are married that were in between 20 and 24. So in 1970, about 65% of women were already married from the ages of 20 to 24, whereas in 2010, only 21% of women were married between the ages of 20 and 24. And so since our slope is about a negative 1, this is telling me that for every year after 1970, when this experiment started, about 1% less females aged 20 to 24 does not get married between 20 and 24 years old. So let's go ahead and write that down. For every year after 1970, about 1% less females aged 20 to 24 do not get married. So there was a decrease in the amount of marriages, about 1% less every year.